Good evening, all. Very warm welcome to yet another session of Landscape Imprints Knowledge Sharing Series and Words of Wisdom by Experts. Myself, Architect Aparna Bhargav, member ISOLA Rajasthan chapter. So, in previous weeks, we have spoken about varied landscape topics. Today, we are going to speak about a very crucial element of landscape, that is water, and we are going to talk about rainwater harvesting systems. So today we have with us a very special guest, Mr. Sunil Sharma from Jaipur. He is an MBA from Lucknow University, 1979. He's first generation industrialist, and over 2 decades he has been taking out his time and his profits from his business venture to experiment on soil and water relationships and pursue his passion about water conservation.
Hello, sir. Welcome to our landscape imprint session. Today I would like to know from your mouth that how do you start with of your project? Please share briefly your process behind designing or improvising rainwater harvesting system of a particular site.
So basically, I always try to tell people this is not rocket science, go for it. This is not rocket science, but as a matter of fact, it is not that easy also. Because if you make a pit, it's about 30 feet deep, and you fill it with water, then the water disappears in half an hour. Then after 15 minutes, after you refill it again, then it goes in 1 hour. You refill it again, then it goes in 24 hours. I mean, then you refill it again, then you will find that it is going down at a speed of say 2 feet per 24 hours. So there is a resistance between the soil and water. They are not very good friends. And now, so what we do, while we are drilling a bore, we have experienced that the strata is different as you see the section, and the soil strata you can't change. It's there by nature. So somewhere you have sand columns, somewhere you have there is a percentage of say 80% sand, 20% clay. Somewhere you have 80% clay, 10% sand. I mean that is the kind of combination which you come across. That is one reason why we concluded that the dia is not important, because if you have a pond of say 2 feet depth, then the strata is going to remain the same. And when you go down, so the depth is more important. The dia is not that important. Now, as we drill the bore, the strata which comes out, the soil which is coming out while we are drilling, that we examine after every 10 feet and 20 feet, and we may prepare a log. And thereafter, we design our structure according to that site. I have some 3,000, 4,000 structures of mine working, and working pretty fine since the last 15, 20, 30 years. But I have never come across the same strata again anywhere. So that is the dynamic nature of the earth. So that is why one formula will not work at all sites. And then we realize that hollow structures which people make so that more and more water can accumulate in them, they do not work because they collapse. Some people dig holes, they put cement rings with slots in them. The water will go out of these slots, and then it is going to recharge the earth. But what happens is the water definitely goes out. Then the silt in the soil, it gets suspended outside, and through the same hole, it starts pouring back into those rings. So the rings, they fill with soil, while you have empty space around. So that's a hollow space. The surface looks the same. You step on them, you will go in because there is no soil underneath. So we learned that way that no, we are not going to make hollow recharge structures. And so that is the process by which we kept on developing. Then one more important thing is that most of the people are working on perceptions. Now, what is your perception? Your perception is as an architect, as a layman, I mean, we all have the same perceptions. Like you pour a glass of water on the soil, the force of gravity is going to pull the soil towards the surface, and then the surface is going to absorb it, and then it is going to travel continuously down till it is absorbed by the aquifer. So you are enriching the water table. Now this is a perception. What actually happens is that when the water, so that means you're looking only at the vertical flow of water. Your imagination is that water table is here, surface is here, water is going to go and get into the table. Nobody's even, in fact, as a matter of fact, I am more focused on horizontal recharge. Horizontal recharge means that the soil has different stratas. What I have done is I have dug a bore, and I have broken that a piece of land there. So this is sand, this is sand. They were like this earlier. So now when I'm putting in water, this is absorbing water from here, maximum, and then it is letting it go further on. At places it is going down also. You can see my hand. Because the force of gravity is always doing its work.
Yes.
In the natural process, what happens is sometimes the groundwater comes on the surface, and you have natural ponds. And once the groundwater is on the surface and you have a natural pond or a natural lake, you can't recharge there.
Yeah.
So I mean, it is a matter of perception. Like silt again is a problem created by perception. That when the silt is going to come, then it's going to choke the system. So the harvesters, they start working more hard on the silt part. And it is simple common sense that during monsoon, there is so much of turbulence, you will never come across and see water anywhere, in a puddle or anywhere, which is as clean as the kind of water you buy in a mineral water bottle. It's always, it looks dirty. It's not dirty. This got suspended. Silt is the lightest particle of soil, so it gets suspended. And if you fill a glass of water with that water and you leave it, then after 24 hours, you'll find that this much of it is clean water.
Right.
Because the sedimentation, since it's light particle, the sedimentation is going to take time. Then the compaction is going to happen, and then the sedimentation will take time. Where is that time during monsoon?
Yeah, that time.
So when you try to, most people, what they do is, and where are you putting their water? End of the day, you're putting it in the soil. So you are filtering it and putting it in the soil.
Yeah.
But we have this concept that, so most people, what they do is they make a tank. They call it a desilting tank. And then there is a pipe from which that rainwater with silt suspended comes and falls in this. And then there is another pipe here. Obviously, this pipe has to be below the level of the inlet pipe.
Yeah.
Otherwise, how will the water go?
True,
so now this pipe is below and this pipe is above, and the water is going to come, fill into this, anticipating that the silt will settle down and the clean water will go into the desilting tank. So what happens if nothing happens? Yes, some silt particles continue falling down. They continue settling down. Unfortunately, if they all settle down, what is going to happen? The silt level will be here. Your outlet pipe is here.
And it will be choked.
So it is choked. How will the water go in? And who is going to clean it? अब baffle wall बनाइए. पानी जो भाग रहा है उसकी स्पीड कम कर दीजिए. And whatever settles down is your good luck. During monsoon, the water quantity is so much that the contaminants, if at all they are there, the dilution levels are massive. Sieving your tea in the morning, 3 times you have to empty the sieve. Otherwise, so for that small work, when you are doing it manually in front of your eyes, you're holding both the things in hand, then you have to again and again clean it. So wo jali laga ke how will you manage? And why are you doing?
Yeah. One of your blog, you were saying like Supporting natural system is sure path to success, and while going against is a recipe to failure. So this connects
Yes,
too much with your thing. Yeah.
I'll tell you.
Yeah.
See, when we talk about natural things, पहाड़ से ग्लेशियर मेल्ट होगा, उसके नीचे से पानी आएगा, रिवर बने, and that river is going down the slope. It's not going up the slope.
True.
This is a natural process.
Yeah.
गर्मी पड़ेगी, एयर हॉट होगी, एक्सपैंड करेगी, लो प्रेशर एरिया डेवलप होगा, colder air will come and take its place. That is how the clouds come during monsoon, and that is how we have rains. So these are all natural processes. पानी जमीन में जाएगा. That is a natural process because God has given us force of gravity, which is pulling everything towards the center of the earth. But there is resistance in the path. कहीं clay आ गया, कहीं hard rock आ गया. So that water, it sometimes works against gravity. And where a drop which falls here, where it is going to meet the aquifer, maybe after 6 months, where it is going to meet, when it is going to meet, we don't know, because it's a natural process. What I have done, I have only created a easy path for the water. They say, it's a saying, old saying, that water takes the easiest path. So I have only created an easy path for the water. Then, see, I always keep telling people there is nothing like physics and chemistry. These are all natural laws. What we study is the interpretation of those natural laws. So, and there is another thing I'll tell you. Atmospheric pressure is very important. People do not know that atmospheric pressure has a role to play in rainwater harvesting. If you've ever seen a pipette and you put your thumb, the water column stops. And the moment you remove your thumb, because of the atmospheric pressure, the water column, otherwise वो रुक जाता है. So atmospheric pressure is also very important. So in our system, we have an air vent pipe for this purpose. And our air vent pipe has got slots. Now there, our experience and the log which we have created helps us, because we know where we have to have the slots. Because when we do the backwashing, we have the jets of water coming, and there is a disturbance in the grid outside. And that is the place where, as I told you, water and soil, they kind of make a film. See, when you take a bath, there's a small film of water created, which you have to remove if you want to see that the drains start working again. The छोटी सी चीजें हैं which we have to understand.
Please share challenges faced while designing this water conservation strategies for Ranthambore National Park. Any
It is not exactly
experiences?
for Ranthambore itself. It is, I have visited that place, and it is not just for Ranthambore. It is for everywhere. See, Ranthambore has got, it's got hilly terrain. Aravalli Mountains and Vindhyachal Mountains. अब वहाँ पे some forest officer or officials, they tried to make bore wells. Tube well उन्होंने dig किया है, tube well they will not get water there. वहाँ क्या है कि जो बरसात में पानी गिर रहा है, वो because of the slope it tries to run away, and it runs off, and नीचे में Chambal River. Now the challenge there is that how you, and from certain points in the mountains there are fractures in the rocks. So at some places the water enters those fractures. फिर, I do not know how many years ago, that was a trade path also. The traders used to cross that Ranthambore path. तो उस समय पे there is a Bawadi also there in the forest area. There is a, तो वहाँ they have open wells. 40 feet, 50 feet गहरे हैं. But they are open wells. They are dug wells. You might have seen some photographs of those wells in one of my blogs.
Yes.
They are not very deep. So what exactly is happening is the water which has entered in the rock fracture somewhere, that again finds a passage and it is trickling into that artificially dug well. अब उसमें पानी भरता है. No, the animal cannot go in and drink water there. Animal does not have the rope and bucket also. So that is what I suggested to them. अच्छा, उसमें क्या है, the fracture from where that water is coming. Once the water level there goes down, then that fracture, the flow of water stops in that fracture. At some places, some fractures are at a lower level. They continue to work. So the best strategy there was to put solar plant and a pump, and for 15 minutes in a day. Not difficult. You put a timer in the pump motor. It will work for 15 minutes. Is going to and have a on the surface only. You make a small pond, very small pond, holding say about 1,000 liters of water kinds, and that pumps out water, puts it in there, and then the animals can come to that pond and they can drink their water. While the abandoned tube wells which they have, they should be used for diverting the water. Once you put the water in that, then it's going to go down. See, the time which you have given me is too short. Otherwise, I'll tell you what happens when you are digging a tube well in a hard rock area. Rock is a solid thing, but it has fractures in it. There are fractures in the rocks. Okay. Now, when we are drilling, what we are doing is we are kind of separating those fractures by this hollow space. So if we connect water to one of those fractures, once it reaches this place where you have this cylindrical hole, what is happening? Earlier on, it was going straight because both of them were connected. And now they are separated. So now from here, it is going to trickle down and fill in here. Once it trickles down and starts filling, and there is another fracture here, which earlier they were not interlinked. Now they are interlinked because now you have kind of interlinked these. So now that facility is there. So these also, then wherever you have slopes high at a higher angle, there are so many rocks there, so many stones there. All you have to do is just manually collect them, put them in the path, break the momentum. Water will not take two directions. If it is flowing this way, it is going to continue flowing this way. And if you have to put it in the ground, you have to have a barrier where it comes and stops and then it starts recharging. It will not continuously go, and because अगर एक नीचे fracture भी है and the water which is coming, the lowest layer of that water is going to form a film over it. And the rest of the water will pass over it. It will not break its journey and start going down also simultaneously. So these you have to learn by experience. If you go against nature, you will surely fail. If you support nature, when they say you go for more tree plantation, what are they asking you to do? Support nature.
So that is everything is in layers, and we have to.
And this is not a challenge. This is not a challenge only at Ranthambore or any of these places. This is a challenge everywhere where the terrain is like this. Amer area is all like this. Focus is like this. 10 feet below the ground, you have the rock. There is no alluvium. So where do you put the water? But fortunately, there are fractures. And in fact, what are we doing? We are drawing water from the rock only.
That is the only option we have.
The unfortunate part is that we are extracting more water and we are recharging less. We have concretized the whole area. We are not concerned about it.
Okay, sir. It was a very nice session. I hope everybody will learn a lot from this and probably will connect again.